So in this presentation, we will be explaining how to do or how to solve TLS at scale. More specifically, we'll actually be going into Erik's setup, the setup that Erik created for one of his clients, where he's actually using Cert-manager in a very advanced way. He set it up such that it's usable within a multi-tenant environment and such that all these tenants can self-service their own certificates. My name is Tim. I work for CyberArk. I'm a Cert-manager maintainer, and so is Erik.
And I'm Erik. I work as a contractor, but for many years I've been working for the Statnett, the Norwegian TSO, which is responsible for the transmission of energy in the Norwegian power grid.
Okay, so a bit more about Cert-manager. Cert-manager, like probably most of you already know, is a CNCF graduated project, and we are very interested in solving X509 on Kubernetes and OpenShift. So if you look at Cert-manager on GitHub, this organization, we have a couple of projects that are very interesting. The most important one, of course, is Cert-manager itself. You have Trust Manager, Approval Policy, and a few others. We'll actually go into those later. We're a fairly popular project, I think. We have almost 12,000 GitHub stars, 400 contributors, and we are being downloaded many, many times per day. And today we will actually be talking about how Erik is using Cert-manager, but that wasn't always the case, I think. So when Erik started with this client, he actually didn't use any Cert-manager at all. So he went from 0 to the point where he is at right now, which is actually being a Cert-manager maintainer. It's like an amazing story, basically. So in this presentation, we'll try to actually take you through the journey that Erik made and kind of show also how he set up Cert-manager for his client and how he really got into this very advanced use case.
Yeah, so first, a bit of context here. I'm used to work as an application developer for many years, also for Statnett. So before joining our platform team, this was a situation. We have multiple Kubernetes clusters and multiple Kafka clusters running on VMs, so not running on Kubernetes. I was using this environment as a developer. But after some time, I joined the application team. This setup was created by a project that had a lot of applications spinned up in a cluster doing a lot of stuff. So, but there was some challenges. Because of time constraints, Kafka was set up without any authentication at all, meaning that data was available for anyone with access to the cluster inside our networks. We have a lot of tenants, meaning independent teams that work on their own schedule. They typically use microservice architecture, meaning we have 1,000 workloads running in our Kubernetes clusters. So at some point, there was a new major project on the horizon, which was supposed to take care of automatic balancing of the market of energy. And it was really no option to keep this situation without any authentication. We had to secure the data. So we started looking into this, and First we decided that we wanted to use the native authorization mechanism in Kafka, which is called Kafka ACLs. But we needed to find a way to authenticate these workloads. So I'm just going to touch into what options you have with Kafka. You basically have two options. You can either use what Kafka calls SASL, that there exists some variants of it, but in general, it requires you to be integrated with an identity provider and also requiring some kind of registration process in the identity provider. In addition, you have the option of using SSL, which is also the Kafka name for it, which means you can authenticate using MTLS. We work in an organization with working in a traditional way, so a lot of manual processes. So we wanted to investigate the MTLS option first in order to not be dependent on any registration process in any identity provider. So we looked at how it works in Kafka, and we soon find out that Kafka doesn't support certificate revocations. So that was an important take from this initial discovery, that we had to head for a relatively short lifetime of the certificate. So to do the authentication, as we say, we wanted to add MTLS authentication. Since we had a lot of microservices, we were sure that we really had to automate this. There was no way we're going to handle the numbers here with the number of application and also the short lifetime. For the same reason, we wanted our users to be self-provisioned because they wanted to work independently and be able to do this without having to go through some kind of manual process asking for certificates. So first of all, we did some proof of concept. You probably have heard of this open source projects, Spiffy and Spirey. They look pretty interesting since they really tailor for what we're trying to do here about workload identities. So we decided to try that first. So we tried to set up Spirey, but we had some challenges running it on our target Kubernetes clusters, which are OpenShift. This is caused by OpenShift enforcing SLinux, and some of the Spirey components are conflicting with some SLinux policies, which means you have to do additional work. Most of these issues are solved now. There's still one open. There's a link there. But there is even a workaround available for it. So now we run Spirey in our dev cluster. But at the time, we couldn't make it work, so we had to look for something else. So we found Cert-manager. It looked pretty interesting. Since we are working in an air-gapped environment, we cannot use Cert-manager for the most typical use case, which is to get certificates from Let's Encrypt. After the work with Spiffy and Spirey, we wanted to take something out of it, the X509 SVIDs. So we set a goal of trying to use Cert-manager to create certificates that look like they could come from Spirey. That means the certificate should contain a URI attribute. And here is one example on how a Spiffy ID might look like for a Kubernetes workload. In our case, we decided to define the trust domain, which is kind of the host name if you look at this as a URL. So you know which cluster the workload lives in. And it's also vital for us to know which namespace the workload is running in, because we use a multi-tenant model where the tenants share the cluster. So one tenant will have one namespace or multiple namespaces, and other tenants will have other namespaces. So that was very important for us. We didn't care too much about the service account at the point because that's inside the same namespace. So it's governed by the same tenant. But there is a huge challenge with Cert-manager in itself, because Cert-manager is made for making it easy to issue certificates. So considering the multi-tenancy, we first of all had to prevent their tenants to tip on each other's toes. You should only get a certificate which the tenant is entitled to receive. And we also wanted some way of enforcing the X509 SVIDs, because we're going to use that information on the authorization layer in Kafka with the Kafka ACLs. So for the V1 version, which we had a very short deadline for, about 6 months, we had to solve this really fast. And cut some corners. I'm going to explain how we did it. The first one was to try to set up a cert-manager for multi-tenancy. We use private PKI, meaning we have a shared common root CA, and we are supposed to use it. We could, of course, create our own PKI, but that was not an option that we thought was very interesting. So we decided to set up a cluster issuer. And since a cluster issuer is available throughout the cluster, we needed a way to control the access to this cert-manager issuer. So the first thing we did was to disable the RBAC permissions for access to the cert-manager custom resources. But that only solves part of the problem, because the cert-manager also have the ingress shim enabled by default. So we had to disable it, because if the ingress shim is enabled, you can just get a certificate by annotating an ingress. And our users are pretty self-provisioned for other resources in the cluster, and we didn't want to change that. At the time, we could also not consider any csi-drivers for the same reasons, because they all end up in the certificate request that we wanted to block our user from getting access to. So now we had everything locked down. But how would our users get access to this feature? Controllers, of course. Can you see this? It might be a bit small. Oh, it's OK. On the top, we have the green box saying application operator. This was an operator we already had in our clusters. The main goal of this operator is to provide a simplified way for our users to schedule a workload. It basically creates a deployment as a minimum, and then by adjusting the specification on the application resource, you can enable more feature without having to create all the underlying resources. So it's very opinionated application resource. So the first thing, this must be available for the users that are using application resource. But we didn't want to force our users to use applications, because we have other users that are using other types of workloads, like a stateful set, or doing other stuff. So we decided in this case to use the service account as the controller for the feature. So by just adding a simple annotation to the service account, we created a new controller identity provider, which watches these service accounts and interacts with cert-manager, creating a resource matching that service account. And then cert-manager kicks in and does its usual stuff. You're probably aware of this. It issues the certificate and returns the certificate inside a secret, which then can be mounted by the workload pods. We're going to look a bit more into details here. You're probably familiar with this, but maybe not all of you. So cert-manager returns the certificate in a secret together with the private key. This allows a workload, like in this case the Kafka client, to mount TLS.crt and TLS.key. And by this way, it's possible to enable an MTLS to the Kafka cluster, which has its certificate and private key. But there is a minor challenge here. We also need some trust establishment. But in our case, we are kind of lucky, because we're using our internal PKI, and all certificates are rooted in our shared company CA. That's why I say on the top here, don't do this. But as I said, we just have 6 months, so we had to cut some corners. This was one of them. We knew it was wrong. Cert-manager provides also csi.crt inside the certificate secret. And since it actually contains the certificate we were looking for, company CA, we decided to mount csi.crt inside the pod and use that as the trust anchor for the Kafka client. This is obviously wrong, and Tim will explain more why.
Yes, so if you're doing this, please pay attention, because, like Erik said, this is not what you should be doing. Actually, the first resource you can kind of look at if you are in this situation is our website. We have a page there where we give a couple of bullet points on why you shouldn't do this. The one that applies here is that by directly mounting ca.crt, it's very hard, or it's impossible basically, to do a CA root rotation or it's impossible to do a CA root rotation if you don't want to have any downtime. So any rotation will result in downtime because there is actually a proper process that you have to go through to do root rotation, which is impossible with this ca.crt. And in this example, there's actually another problem, and that is that we are using the CA of the Kafka client certificate chain. While what we actually want to verify is, of course, the identity of the Kafka server. So, for example, one case in which this will go wrong is if the Kafka client is suddenly rooted in a different CA, in the new company CA. So, in this case, what will happen is, because we are mounting the ca.crt in the client, in the trust store, the client will suddenly only start trusting the certificates rooted in the new company CA. But like we said before, the Kafka cluster is still using the old company CA. And so this is like this weird situation where, because the Kafka client actually changed root CAs, it also started trusting a different CA. So what we should do instead is we should actually trust the company CA, the roots of this cluster CA chain. So this is actually the right arrow that we should draw. But this is not that easy because that isn't normally available in the cluster. Erik, like he said, he had that ca.crt available, so he just used it. And also in his case, this wasn't like a different CA, so he didn't see any problems. But once you're kind of changing your setup, then you get into these problems, and this is like an instant way to get you into some trouble and to get some downtime. There's actually a good solution for this, something that Erik, I think, implemented in his next version of his tool, or his setup.
Yeah, so just showing this short title slide. There were some issues in V1. It was running in production. There were no real issues with it. And it was a huge success. But we started knowing that a root rotation was approaching. So we needed to solve this some way because we didn't want our workloads to break down. And we also had requests for using Cert-manager for other use cases. So the way we had to lock down Cert-manager was really unfortunate. So we're looking for ways to solve this. And Tim will explain more about how we solved the first thing.
So in this slide, you can actually see what you should do instead of what Erik did with the ca.crt field of the certificate, of the secrets. Instead, what you should use is Trust Manager, another project that we have. I'm a great salesman, I know. So this is another controller that you install in the cluster, and you configure it through these bundle resources, which is a custom resource that you can use once you install Trust Manager. And basically, Trust Manager kind of allows you to configure a set of sources containing a set of certificates that you want to trust. And then, as outputs of this bundle, actually new config maps are created across different namespaces that you can then mount in your container where you're actually wanting to have those certificates in your trust bundle. So in this case, we have a bundle that contains company CA, and the Kafka client chain has migrated to new company CA, but that's not a problem because the trust bundle is still containing company CA instead. So the Kafka client will actually be able to do MTLS without any issues. So what happens now if we also decide that the Kafka server or the Kafka cluster wants to migrate to the new CA, right? Then in order to do that without any downtime, the first thing you have to do before you do anything is you actually want to make sure that all the clients also start trusting the new company CA. And the easy way to do that with this Trust Manager bundle, and this wasn't possible before with the ca.crt field, is you actually just add another CA to this trust bundle. So you add the new company CA to the trust bundle, and now the client just supports both. And once you do this, and once you restart all the clients, make sure that they all load in this new trust bundle, you can actually start porting over all the Kafka clusters to the new company CA, to identities that root in this new company CA, because those will be trusted by the clients now too. So you can have this mix of new company CA identities and old company CA identities. And once you fully migrate to all new company CA identities, you can actually untrust the old company CA. So that's the full migration kind of explained, and that's why you should use Trust Manager, because this is not possible to do without any downtime if you're just using ca.crt. Then it will just instantaneously switch from company CA to new company CA, and like half of your applications will break. This is what the resource looks like in YAML. So you have this bundle with a set of sources defined that live in config maps, and then you have the target, which is also config map, a namespace selector, which says in which namespaces these config maps should be created so that they are available to be mounted in the pods. And then Erik will now explain in more detail the second problem he solved in V2.
Yeah, the second problem was that we wanted to unlock Cert-manager again, but we still had the same requirements that I introduced with. After some time, a new project popped up called Approver Policy. That is a plugin for Cert-manager, which allows you to define policies of how the certificate should look like and where they should be available. In our case, they were almost feature complete for what we trying to solve, at least on some parts of it. But what we were missing was to kind of attach the policy to the namespace, because since we again are running multiple tenants in a cluster, we want to ensure that the certificate somehow is linked to where the namespace of the certificate is requested. But that was solved by contributing the cell support, which is a really cool feature, I think personally. So it can have a lot of other use cases. You probably know cell from upstream Kubernetes. Now Tim is going to explain a bit more on the details of Approver Policy.
Yes, so by...
Sorry. So by introducing Approver Policy, we could reverse all the things that we have done previously. So now certificates and certificate requests were available, and also in Gresham we want to experiment with ACME, and we are also considering the csi-driver. Sorry about that.
Yes, so as Erik explained, he opened up all these resources again to his tenants, but now we need a different way to kind of protect which certificates are being issued and which are not. And so the way you do that is through these approval plugins. So let's go through the whole flow here. Okay, so a tenant creates a certificate that results in a certificate request being created automatically, or they can also directly create a certificate request manually. And then a certificate request is really the resource that will be considered by a Cert-manager issuer. But before that happens, the issuer will actually check, does this certificate request have a condition, an approval condition that is set to approved. If it doesn't have that, it will actually wait. If it has one that's set to denied, it will actually say, okay, I'll not do anything with this certificate request. So by default, when you install Cert-manager, there's this approve all approver, which approves all the certificate requests it sees, which is great to get started. But what Erik needed is some more control. And for that, you can actually disable the default approver and instead use approve policy. An approve policy is this plugin that you can configure through these certificate request policy resources. This is basically a description of what certificate requests you want to approve when you see them. So in this case, this is a policy that will approve client certificates. And the one check that it will perform here is that all the URIs in the client certificates actually starts with this spiffy prefix. And the spiffy prefix in this case contains the namespace of this certificate request resource. So that way we are sure that when a certificate request is created, before it gets issued, we actually make sure that the URI in that certificate request actually matches the namespace in which the certificate request lives. And that way, we make sure that there's like no certificate request created for another tenant or another namespace in Erik's setup. The same you can also use to configure server certificates. And here instead, we actually do checks on the DNS names instead. Also check that they, in this case, have a suffix with the namespace. So to conclude, when you want to scale your TLS setup, there are 3 things that are very important. But first, scale is kind of a very hard problem to solve because you have many certificates. You also have many tenants with different requirements, also many clusters possible. So the first thing you want to solve is you want to automate like the very basics. You want to automate the certificate lifecycle and also the distribution. So for that, use Cert-manager, Trust Manager. The second thing that we saw is you want to make sure that once that is automated, you can give the tenants in your setup the ability to kind of self-provision everything. But you want them to be able to do that without breaking all the tenants. So you set up policies. And these policies you can configure through approve policy. And then the last one, we didn't really talk about this, but it's also very important. You have to make sure that all your automation is monitored so that when something goes wrong, when automation breaks, you get an alert, or when a policy is not adhered to, you also are notified of that. So that's the conclusion. Thank you for listening. I would like to hear if there are any questions and any kind of feedback you can leave through this QR code. Thank you.
Microphone there, if questions.
How are you doing the monitoring?
Well, there are multiple different solutions for that, I think. I'm not sure which one Erik is using. I think maybe some...
Prometheus metrics?
Prometheus metrics, yes. And you, like the cube states metrics? Or
yeah, we use some of this. I'm looking in this direction. My cluster admin is here also. We also set up some custom monitoring of the CA because we want to know what's the earliest certificate that expires in your chain and get an early warning about that one. So we typically use Prometheus, Grafana.
There are also various commercial solutions available for that.
You mount it the normal way because the trust bundle is delivered as in a config map.
If it changes, then how do you...
Oh, that's a good question. I had actually in my original presentation prepared. We use a community project called Reloader. Some of you might have heard of it. So that way it watches a config map or a secret, and whenever it changes, it will trigger a rolling update of your workload.
That's also very important for the certificates themselves when they change. The trust store probably won't change that much, but the certificate itself, when it changes, you must make sure that the application loads a new certificate in time, otherwise you'll have downtime, basically.
First over there.
Hi, when you were initially doing the migrations and when you had the thousands of services and using the trust bundle, did you have any issues? Like, for example, when I last used that, there was an issue that some of the services were using like some certain libraries which were only checking the first certificate in the bundle.
No, we didn't have a problem with that. There are no changes in the CI bundle. There's only typically only root certificates, like self-signed certificates.
So in the bundle you have the old CA and the new CA, right?
Yeah, but they're both self-signed. So they're not chains really. They're form different chains. There?
Yeah. Do you have an issue? Have you compared issuers with your private CA, or you have a signing certificate in cluster?
We had different solutions over time. We started out with a CA issuer. So we had to order an intermediate or subordinate CA inside our private PKI, which we initially installed as a CA issuer. It's not recommended. It's not that secure. So now we're running it externally. So we run it in HashiCorp Vault using the PKI engine. So Cert-manager just sends the certificate signing request to Vault, and you get the signed certificate back. So Cert-manager takes care of the automation and all this renewal and everything. That allows us also to set up extra security in Vault, because we also have the policy again repeated in Vault, so as an extra layer.
Yep, thank you.
The one thing that you cannot do, or that's hard to do, is in Vault you cannot say, for example, that the namespace has to be in the URI, so therefore you need approved policy, because it isn't aware of what namespace is. So you could also solve that by having like different issuers in each namespace. That makes it so that you have to have a lot of different issuers basically. Yeah.
But we use the policies involved to kind of, we have one issuer per cluster, so we ensure the first part of the SPIFFE ID, so we know that we're not having environments going across. Any more questions?
Okay, thank you for listening.
Thank you.